Yo, what's going on, everybody? Today I'm going to be creating part 3, 4, and 5 because the last 3 days I haven't uploaded. But it's not because, hold on, my gain is kind of high. Hold on. The reason I didn't upload was because I had a lot of interviews, a lot of meetings, and I don't know, I've just been very busy. And also, I did record, the files just crashed. So it's like, what can I really do about that, right? All right, so now we're gonna be attempting valid Sudoku. Let's just get straight into it. Determine if a 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 through 9 without rep. I don't play Sudoku. Ah, okay, so row is like this. Column is like this. So 1 through 9 without repetition. 1 through 9 without repetition. Each of the 9 3 by 3 sub boxes of the grid must contain a 1 through 9 without repetition. Let me see if this is picking up my... Okay, I might need to up my gain just a little bit. Yo, nope. Max out gain. Let me try this now. Oh wow. Is this better? Okay, yeah, it's way better. Okay. So each row must contain 1 through 9 without repetition. Each column 1 through 9 without repetition. Each of the 9 3 by 3 subboxes of the grid must contain digits 1 through 9 without. Okay. This is gonna be like a pain to solve, bro. So we're using a 2D matrix. Okay. So so row 1 through 9 unique. Call 1 through 9 unique. Uh 3 by 3. So we have 3 conditions. So how do we meet these conditions? We have to we have to validate the row, the column, and the box all at the same time. That's 3 validations. And it's a 2D matrix, so it's probably going to be... All right, so how do we validate boxes first off? Because that's going to be like the biggest bottleneck. I can easily validate a row and a column, but how do I validate the box? So we return true or false. Only the filled cells need to be validated. And this is the input right here. So everything is a character. They're not actually using integers. So we're validating characters. Would we have to convert characters to integers to do valid comparisons? Or can we just set them equal and check if they're equal? I don't know. Okay, so we need to divide this. So we have a 3 by 3, a 3 by 3, a 3. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 boxes. All right. So should we validate the boxes first and then validate the rows and the columns? So this is what I'm thinking. I'm just gonna like use like caveman brain and just try something. So we're gonna validate, because this is gonna be the hardest thing to do. Validate boxes first, then rows and calls. Okay. So in order to validate these boxes, we have to divide it into 9 subcategories. How do we divide it into 9 subcategories? So we know a box is 3 by 3. So we'll do box equals 3 by 3. And we have 3 on top. We have 3 rows and calls of boxes. So the indexes would be 0 through 2, 3 through 5, and then 6 through 8. And this logic applies for rows and columns as far as the boxes. So each of these are boxes. And so a box is going to be like 0 through 2 going both ways. But then we have to hit the middle boxes, and so we would have like all these combinations. Damn, this is like actually cooking me, I'm not gonna lie. Alright, so let's do, we have a vector of vectors. So I'm assuming each one of these counts as a vector. No. So this is one vector. The vector holds all the vectors. That makes sense. So one vector holds all vectors, and each vector is comprised of each vector is literally a row. That's what I'm saying right here, because I see a comma right here. So this is 1 2 3 4 5 6 7 8 9 total vectors. So this would be index 0 through 8. So for this one, it would be, to access that vector would be 1, and then I have it would be 0, and then I would have 0 through 8. And so the next one would be 1, and I have 0 through 8. And the next one would be 2, 0 through 8. So I need to figure out how to divide this into sub boxes. Alright. I don't see a fast way of doing this. So to start off, I'm just going to hit our return statement. So bool is now for the actual logic. We're going to have to use for loops. Going by rows and columns, so I should probably just do like row equals 0, row less than I have a better idea. We'll just stick to I. Should be integers. Damn, this is gonna be okay. So I'm just gonna divide these into boxes. I'm gonna like, I'm gonna just do this. All right. So the row that we're going for is at 0, and then I think 2. And we're gonna do the same thing for the column. So do 4 and j equals 0. J less than 2. J plus plus. Alright, so now in here we can access each box. So now we just go through and check if any of these are equal to each other, right? I feel like logically that makes the most sense. But the time complexity for this is going to be like fucking crazy. So we do... So we skip 0, 0. Because obviously it's going to be the same. We're gonna create a new array. Right? Okay, I have an idea. We create an array, and then we make that array a box. Then with that box, we do another loop, which checks if everything is unique. If everything is unique, then it goes through, and we pretty much do the same thing for the next. Okay, and instead of doing 2, I'm gonna do this. Watch. I'm gonna go right here. I'm gonna do this, and then I'm gonna do this. And then like at the end of every pass, we'll do like row, do like if row less than 9, right? If row less than 9, we'll do row plus equals y at 2. That'll put it, we'll do plus equals 3. So right now what I'm doing is I'm incrementing the row count and the column count each time by row or, and I'm doing this because I don't want to use like a repetitive amount of loops. So we'll do another one. We'll do 4. And so it should only be 3. We'll do k. So this should pass exactly 3 times. Just for spacing. Okay, so we have a try loop. And so this one is going to validate our boxes using the logic I was explaining. And then once we validate the box, we'll bump this one up by we'll bump the row up by 3 and the column. We can't bump them both. Hold on, I gotta use the bathroom. All right, so where were we? Okay, yeah, so we got bottlenecks, right? So we can't bump up the row and the column at the same time. We got to do the rows first and then start doing the columns. So I guess we can work vertically or horizontally. So we would have to do bump the row up by 3, boom, go here. Bump the row up by 3, go here, boom. And then bump the column up by 3. Okay, no. Yeah, we can do that. Bump the column up by 3. And we'd go here. And then take the row down by 3, take the row down by 3, and then bump the column up by 3, and then take the row down by 3, and then take the row down by 3. So kind of like a zigzag. That's what I'm thinking right now. So how would I implement this logic? So to bump the row up by 3, we'll do that. And row is going to equal 8. So we'll do row plus equals 3. We need a condition that'll take us to bump up the column. So we'll do like a bool. Bool is call bumped. So once column bumped is true, we'll make this an integer. Sorry, this is easier. I'll make this an integer. Once column bumped equals 1, then we start decrementing. So we'll do if column bumped equals 1, then we can start doing row minus equals 3 until we get back to 0. And this should only bump if we get to 9. So we'll do like if row equals, or if it equals 8. Oh, this should never be 2. I mean, this should never be. Yeah, so it should be capped off at 2. Okay, so if we have row equals 8, and if row equals 8, we'll do call bump plus equals 1. And so once, so this is my logic, right? So once this equals 8, we're going to increment this by 1. It's going to repass one more time. It's going to repass one more time, which is perfect because then the column's bumped right here and we do that again. And then this is going to finally ring out. If row equals 8 and call does not equal 1. We have to implement this condition because we don't want this bumping up twice. If call bumped equals 1, we can't do this like right after, so we would have to go like this. And we would also have to do call bumped equals 0 again. That makes sense. Okay, so I think this works now, right? So call bumped starts at 0. So this isn't going to apply. If row equals 8 and column bump does not equal 1. Okay, so this applies whenever row is equal to 8. Row starts off at 2. So we'll do row plus equals 3, which will take us to 5. And then we'll do this square. Then we do it again, which takes us to 8. So we'll do this square. Then this applies, and column bumped equals 1. So with this being 1, we have to pause on this. So we have to do if call it's not equal 1. Okay, so now if column bump does not equal 1, then we can do that. But if it is equal to 1, which it will be by the time we get here, we're not going to increment it. We're going to keep it exactly how it is. All right. Now we bump down here, and we got to get our, and then column bump is going to be 1 by now. So we're going to keep this, and we're going to do -3. We can't do 0 yet. We'll do if row equals 2, then we can do call bumped equals 0 again. Does that make sense? Does that make sense? So we're gonna get, okay, so we're gonna go through our logic. We're gonna get here, and we're gonna do -3, so it's gonna take us to 5. We're gonna do -3 again, that's gonna take us to 2. And now that we're at 2, column bumped is going to equal 0. And with column bumped equaling 0, our row is gonna increment again. We have to wait one pass. We have to wait one pass. So how do I wait one pass? We'll implement a wait. We'll do int wait equals 1. So wait's gonna equal 1, so we're gonna skip that one. And then we need a condition to deactivate our wait. After this, we can do if row equals 2, we can do this because it would have already implemented itself, right? Does that make sense? So let me just try to go through this square. We don't even have our logic for incrementing or decrementing the column yet. This is crazy. Okay. So this is what's going to happen. So if column bump does not equal 1 and weight does not equal 1, they don't equal 1. We're going to do plus 3, so we're going to do 5. They're not going to equal it again, so we do, what is this, 9? Not 9, 8. We do 8. And now that we have 8, we're going to increment this column bump to 1. If column bump does not equal 1, which it does, so we're just going to skip this. This doesn't even apply because it's at 8. And it's going to go through again. And column bump does not, it equals 1 now. So column bumped equals 1. So we do row minus equals 3, which is going to take us, because we already did this one, which is going to take us to 5. And then we're going to pass through again, and this is going to take us to 2. And then we do if row equals 2, column bumped equals 0. And we have int weight equals 1, because we want to do this one again. And so we do if row equals 8, and column bump does not equal 1, column bump plus equals. So column bump is going to go back to 1. If column bump does not equal 1 and wait. If column bump does not equal 1, row plus 3. Okay, yeah, so column bump does not equal 1. And then we'll do if row equals 2, then weight equals 0. Which it is. I'm so lost. I don't know what I'm doing. I can't solve this. I need a hint. Bro, I'm like hard coding like hell, bro. How long have I been at this problem for? Because, like, even if I do this approach and it works, bro, this shit is not like when in doubt, ChatGPT it out. Let's see this solution, bro. Maybe I could learn from the solution. So, box index. Okay, this is pretty smart. 3 plus column divided by 3. I'm trying to figure out this box index. So they do row divided by 3. Where the fuck is row coming from? And then they do times 3 plus column divided by 3. And that's the box index. So they're dividing it into boxes. So they do a vector, an unordered set of characters. Rows 9, columns 9, boxes 9. I don't understand the syntax. I've never seen this before. So they have a vector of unordered sets, and each set is comprised of characters. We have 3 sets comprised of 9 characters each. We have 9 boxes, and we have 9 rows, and we have 9 columns. So we do r equals 0 for r less than 9, r plus plus. And this ends where? Here. So we do a nested for loop for int c. What does c stand for? I don't. Columns. Okay, rows and columns. Okay. Columns less than 9. So we have a character val equals board rows and columns. Okay. If val equals dot continue. I wasn't even thinking about that. I wouldn't have got that because I didn't even know about that. So we're skipping the empty cells. So the box index is the row divided by 3 times 3. So let's just do some math. So if we're in row 1, we do 1 divided by 3, which is 0. Times 3 is 0. Okay, so we're getting the box index because from 0 to 2, if you divide by 3, it's going to equal 0. And then once you get to 3, you multiply that by 3. I mean, you get 1, and then you multiply that by 3. That doesn't make any sense. Once r equals 3, we're in the second box. So why are we multiplying by 3 to get 9? I mean, we're multiplying 1 by 3, so we get 3. And let's say we're in the first column. Let me just try to map this shit out. So if we're in so rows are like this, columns are like this. So if we're in the third row, the rows don't even go to, I guess the rows go to 9, right? So there's 9 rows. So if we're in the third one. Okay, so they're clearly not using like regular indexing, right? I'm just gonna go 4, play it safe. 0, 1, 2, 3, 4. 4 would put us in the second box. All right. We do 4 divided by 3. We get 1. We get 1 times 3 is 3. Plus C, which is 1. So I have 0. Box index is 3. Zero top left. 1 top middle. 2 top right. 3 middle left. Oh, okay. Damn. That's that breakthrough moment right there. Wow. Okay. That makes sense. And then they do if rows dot count val. Okay, so if the value exists in row R, return false, and then we insert it, and then we check if it exists, return false. Bro, this is like actually like, bro. Okay, that actually does make sense. So we don't even need to return this. They do an unordered set, I believe. They do like some weird shit. A vector of unordered sets of characters. Like, what the fuck? Vector. And then they do like row. Um, is it Valor box? I think it's box. So one thing I do know about like lead code problems, you're not supposed to memorize the problems or like the code. You're supposed to memorize the way to actually solve the problem. Because there'll be like spin-offs or variants. So the trick here is obtaining the box index using the rows and the columns. And I'm thinking of this as like a square. They're thinking of it as like just like a horizontal 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. I feel like I'm just copying code right now. Like if I'm gonna just copy code, I might as well just copy code, right? And I guess I'm gonna have to like study up on this and like, because obviously I didn't get it first try. No way GPT-5 is getting them wrong. And so if I was to get this right, I would be in the top 1%. But I need to learn how to do this, and I will off camera. And then yeah, this shit kind of I don't know what type of solution I was trying to come up with, but I guess I got to think outside the box. No pun intended. Um I have a lot of work to do.